Hello, everyone. Here I am again. I'm Cola Sebas from Ateneo de Zamboanga University, Mathematics Department, College of Science and Information Technology. Today, we will be discussing on the independent two-sample t-test. So let's try to look into this data. Okay, so again, this data is about the salary of the government employees in Zamboanga City. Now, by this time, we are going to compute the independent two-sample t-test. How are we going to compute this? Um, since that the presentation of data here is mixed, no? They are not arranged. So what we're going to do, we are going to arrange the data. And then before we are going to compute the independent two samples t-test, we are going to compute first the F-test. The F-test will test the two groups of independent samples if they have equal variances or unequal variances. Our null hypothesis here is there is equal variances between the two groups of data. The alternative hypothesis is there is unequal, no, not equal variances of the two groups of data. Okay, so before we compute that, we are going to arrange the, the data according to the sex, no? Female and male. So what I'm going to do here, I will be highlighting the data. Okay, and then I'll go to data, go to sort, and go to sort by, click, and then you sort this by sex. Okay, so you notice that this is now arranged, no, according to female and male. So we can now copy the data and we can already treat the data. So what we are going to do here, according to the legend that one is female, two is male. So we are going to type here the the male or the female and next male. Okay, and then um, we copy now the salary because we're going to compare the salary of the male and female. Which one has significantly higher salary? It is, there you are, and then we go to the male. Then, okay, let me get at this. What we're going to do now, so we are going to write first the null hypothesis. Our null hypothesis here is there is an equal variances on the salary of the female and male employees. Our alternative hypothesis, there is an unequal variances on the salary of the female and male employees. Okay, so let's try to find out if we are going to reject the null hypothesis or not. Now, what we're going to do, we go to data analysis. Okay, then we go to F-test. What you're going to do is you click the variable 1, which is for the female. And let's try to click the salaries for the female. Then click for the range for the variable 2, which is the male. Then click these salaries. There you are. And then you click the output range. Okay, so let's say we want to have our output here. Okay, then click OK. This is female, and we have for the male. Okay, so let's try to check no the p-value. You notice that the p-value here is we have a scientific notation with -10. So what do you mean by this, no? If you're going to check with this is almost zero. So you will notice that the p-value here is less than the alpha. Okay, so let's say uh, test here is for the variances. We only have one tail test, no? So we let alpha be equal to 5%. So let us, if the p-value is greater than the alpha, then you fail to reject the null hypothesis and accept the null hypothesis. If the p-value is less than alpha, then you reject the null hypothesis and accept the alternative hypothesis. Now let us try to check, no? If the p-value is greater than the alpha, then you fail to reject the null hypothesis. Of course, you accept the null hypothesis. If the p-value is less than the alpha, then you reject the null hypothesis and accept the alternative hypothesis. So by symbol, p-value is greater than alpha, then you fail to reject the null hypothesis. If the p-value is less than alpha, then you reject the null hypothesis. In this case, we know that the p-value here is less than alpha, since that our scientific notation here is -10. So you have to move the decimal places uh, from left to right to reach the -10, no? Scientific notation. And that is almost zero. So therefore, 5% is greater than the p-value for the one-tailed test. So what do you mean by this? Since that the p-value is less than alpha, so therefore, we reject the null hypothesis and accept the alternative hypothesis. So this means that there is unequal variances, not equal variances. If you are going to test this t-test, we are going to use the unequal variances. Okay. Okay, so let us now use the t-test for unequal variances to find out if there is a significant difference on the salary between the female and male employees. So let's say to find out. So we are going to write the null hypothesis that there is no significant difference on the salary of the female and male employees. And our alternative hypothesis, there is a significant difference on the salary of the female and male employees. And let us try to set our alpha. Our alpha here is 5% two-tailed. So we divide alpha into 2, alpha over 2. This is equivalent to 2.5% or 0.025. So this is our alpha. No? We are going to compare now later on the result of the p-value of this uh, t-test. So click the data analysis. Of course, no, you go to data, then click data analysis. And then we are going to have the t-test assuming unequal variances. Okay, then we are going to click the first variable, which is for the female. And we are going to click the salaries for the male. Okay, this is alpha. Click the output range. Let's try to check where are we going to put your output range. So let's say we are going to put this together and then click. Okay, there you are. Let us try to interpret the data. Again, this is for the female. Okay, so we have female and male. So the mean for the female is about 24,924, and the mean salary of the male is 54,888. Let's try to check. Now, this is our p-value, 0.00385,911. So we are going to compare now with alpha over 2. So this is two-tailed. Let me copy this. Say up to this one. And then we are going to check with the p value. But we know that the p value is less than alpha over 2. So we are going to write it here. Then the p value, of course, okay, the p value is equal to this. And we are going to compare question mark, of course, but I already write it here, no? That assuming that the p value is really less than alpha over 2. And then for alpha over 2, this is equal to 0.025. Okay. For the comparison, the p-value is 0.0038591. So this is actually less than alpha over 2. So we reject the null hypothesis and accept the alternative hypothesis. So what would be our conclusion now? Since that this is the result. Our conclusion, since the p-value is less than alpha over 2, then reject the null hypothesis and accept the alternative hypothesis. Therefore, there is a significant difference on the salary of the female and male employees. Since the mean salary for male is greater than the female, this means that the salary of the male employees is significantly higher than the female employees. So this is how we interpret for the independent two samples t-test.